Okay, hi everybody, this is Sister Dora. I'm calling in from Brookline, Massachusetts. I am the Education Events Coordinator for NOFA Mass, and I'll be your host for this evening. Welcome to the Bioremediation of Urban Soils event with Andrew Laurion, who is the coordinator for NOFA Mass. Before we get started, I'd like to thank all NOFA staff and board members who have helped to make this online event possible. Thanks to our sponsors, the Massachusetts Department of Agricultural Resources, MDAR, and of course, most importantly, we would like to thank all of you. A couple of house cleaning rules. If you have any questions, put them in the chat. If you have any, well, maybe once in a while, we'll probably be asking you to unmute your phone so you can come on. If we don't understand your questions after that, please mute your phones so you won't disturb the presenters. So with that being said, we would like to welcome Andrew Laurion. The floor is yours.
Thank you, Sister Dora. Let's get this started here. All right, welcome everybody. This is our online education event. I'm here with the youth at GTC in Springfield, Mass. So if you hear me take a pause, I'll just be answering a couple questions that we have here live as well. So this is about bioremediation in Springfield, where we're approaching potentially contaminated or damaged soils, and we're trying to remediate it using natural methods. And again, I'd like to echo Sister Dora on thanking everybody who's involved and all the hard work these youth do in Springfield to reclaim their spaces. So bioremediation is a process used to treat contaminated media, including water, soil, subsurface material, by altering environmental conditions to stimulate growth of microorganisms and degrade the target pollutants. It's most commonly seen in the bigger oil spills and soils that are contaminated through various reasons. Okay? So what is it? What's first? What's the process? It's hard to say that there's rules to this, so I'm not going to go there. And when you try to plan things out, things might end up looking like this down the road, just so you know, like things aren't always linear. But this is how we're going to do it. We're going to start off with site observations. So the most important thing you could do when you're about to grow a garden, whether it's your home or a vacant lot, something like that, you want to just observe the area, okay? Like, take all the observations of what's there and utilize Google Maps to tell you a little bit about the history of it. As you can see, these were taken some time ago. These photos are photos of Franklin Street, one of the sites that we're going to remediate. And you can see right here, there was a garage or a driveway where cars were worked on. And this right here is our site where we're remediating. So it's kind of like laid on top of what used to be a garage and a work area. And then on this 3D map, you can see the contours that has changed over time. So it's good to utilize these maps to figure out what your space had looked like. And the observations are key. Like, use your eyes, your ears, your nose, your skin. Like, draw what you see. Take pictures and document everything you can witness, because that is what's going to be the comparable information. That's going to be where you start to figure out where you're going to go. So, like, what birds do you hear? What machinery? Is there cars in the background? How do you feel in this space? Do you feel safe working in the space? Do you feel good? Do you feel like you're making a difference? These are all part of the remediation process. And you want to touch the soil. Is it dry? Is it soft? Is it crumbly, dusty, gritty, smooth? You can write it all down. And take pictures and don't drop the ball on that. This is a more simple observation sheet that one of our youth had taken on Franklin Street. So, you know, what cars you hear, and this is like every day we'll do this. So it's not always like an expensive thing. It's just to get your mind open on what's happening. So we heard some cars, there's a highway. We did microtraps, which we'll talk about in a few. So we have recorded what we've seen on that. Very simple observation sheet. Soil surface biology assessment identifies a ratio between bare soil and covered soil. The amount of soil crusting, living cover, plant species, diversity, and non-plant life forms are also quantified. Soil with a lot of coverage promotes better soil health. Non-plant life forms, including insects, fungi, and animal burrows, also indicate good health. As we said before, like you've seen those naked soils without any grass or any things on it. That's not a healthy soil, most likely, and you will see weeds moving in to kind of take over the space and heal the soil. So, talking about observations, this is kind of an easy way to take like a space that is representative of your whole lot. So what you want to do is place the hoop, your observation hoop, over an area that you think best represents the lot that you're studying, and just identify what's there. It'll tell you a lot. So like in this little hoop right here, we can see a dandelion, some crabgrass, recently added fescue mix, and then you can see that like 10% of that soil is exposed. It doesn't look like well covered. Here's some of the youth here where we're going to break ground. So we want to take our observations above the soil, and we want to take our observations below the surface, what we'll call the subsoil. Yes, sir. What's a crabgrass? It's a Hey Nancy, do you have a better answer to this? If you're there, I think a crabgrass is just like one of those invasive grasses that you see all over.
Yeah, crabgrass tends to creep all over the ground and send roots along creeping structures, so it tends to carpet areas really strongly and quickly.
Would you say that it's even like doing its job to remediate the soil?
I couldn't say that one way or another. I think that is revealed when you test it. It is pretty surface level in its how it's engaging the soil, so it would only remediate the area where its roots occupy, which is the very surface of the soil. So if there's contaminants there, that's what it would remediate.
So that's cool to think about. Later in our slides, we're talking about plants and how they occupy space. So it's good that you pointed that out. The roots they only go but so far. So how much could it actually remediate? That's our team that was with us in the beginning. There's Carol Roselle and Naveen Ismail from Smith College and American Farmland Trust now. Carol. They've given us a wealth of knowledge of how to approach these contaminated soils. You can see we got our little equipment here. None of it is really expensive. So this is another observation or a test we can do to determine the quality of our soil. This is a water infiltration test, and it indirectly measures soil structure and potential compaction. So what we're doing is like we'll take this round plastic, right? And we'll knock it into the ground with a hammer just a little bit, and then we'll get a timer ready, and we'll fill that with water and see how long it takes to drain. If it goes fast, if it goes down well into the soil, that means we have a soil that is healthy and it has a lot of good pores and aggregates to absorb it. And if it's compacted, a really poor soil, there's a chance that water is just going to sit on top. So for this particular test on Franklin Street, there was no filtration after 30 minutes. It did rain in the previous days, but 30 minutes is a long time, and that's an indicator of compaction or poor soil. The Flake Test assess how well soil stays together, aggregated when submerged in water. So you'll take like a clump of the soil that you find in the hole, and you'll put it on the top, you make like a basket out of this metal right here. You made a little galvanized mesh, and we'll place the root ball on top of that water and see how long it takes for the water to dissolve it down, right? So we're looking at how long that it takes and how cloudy the water is. Here, about 15% of the soil fell to the bottom, and there's charts that you can use to compare like cloudiness. And on our chart that we had a 2 out of 4 cloudiness. So here's another one. You can see this is like completely dark, completely brown. So that soil was just really loose, and it didn't have anything to kind of no structure to keep it together. So in that hole, you know, you want to dig a 1 foot cubic hole, and you want to measure where it was that you did that. So if you ever need to come back to the space, or you know, just to give you a sense of where you are in your plot, you want to say like it's 41 feet from the fence on Franklin Street, okay? And 28 feet from the fence on Crane Street. That way we know exactly which area we're testing if we ever need to resort back there. So earthworms. Earthworms are a good sign, or, you know, they are a decomposer of the soil and organic matter, and they turn it into carbon, improving plant nutrient availability, developing soil pores, and establishing and maintaining soil structure and aggregate. Tightly linking them to soil carbon content and overall soil health. So when we dug our first hole, found not a worm, no worms at all. So there's nothing in there to kind of push around the soil and break it down as far as that goes. Soil hardness provides a measure of soil compaction. Soil compaction makes it difficult for plants to send roots down for growth and stability. Reduces water infiltration, leading to erosion, and reduces populations of soil microbes essential to maintaining soil structure and health. Soil hardness is measured by using a pentometer in both the growing area and head growth for comparison. Most crops cannot send roots into the soil requiring penetration pressure of 300 pounds per square inch. So when we were doing this test, we were getting like 225 PSI on sometimes 300 or greater. So soil site observations are key. They tell you a lot about the soil. They tell you a lot about the space you're in. And what's next would be some soil tests, at least for us. Okay. So we're taking soil samples. We have this core here, but if you don't, you can use just a garden shovel, or, you know, a regular hoe, and just gather up soil samples in different spots of the plot you're testing, so you can get some qualitative data. This is Josh from Home City Housing taking these samples, and you can send them off to a lab. We've used UMass Extension, Page Laboratory. We used UConn before, and we use Contest Labs in East Long Meadow. So right now they're offering free soil testing at the Mason Square Library. So if you're interested and you're in the Springfield area, you want to grow something in your yard or whatnot, you're able to go to the Mason Library, you pick up this envelope, and you can send off your sample to UMass, where they'll tell you a soil analysis. So after we get all our information, we get our results, all of our pictures, our data, we measure our site, what's what, then we reach out for consultation, okay? So whether that's our own research, where we're looking up books and articles, scouring the internet, or you have access to people in the field that are professionals. Now, I hope nobody kills me. Nance, I know you're on this line right now. I think I saw Ruben on there for getting these pictures and putting them up here, but these are some of our consultants. Okay? So this is Willy Crosby from Fungi Ally, where we are getting our mushroom spawn. Some of you were involved with spreading mushroom spawn mixed with hay on our lot. And on Franklin Street, we did it as well. So we got Nancy Clem here, who's awesome. I believe she had just recently returned from Mexico, where she's doing some studies. And, well, I actually don't know what you're doing there, Nancy. We haven't got to talk yet. But she's worked in the Amazon as well, and from Chicago and many places, much experience. So it's great to have you here on the line to ask these hard-hitting questions. And this is just the, YouTube, Google, to go out there and get some information. Okay. Then after this, after we get our consultation and we get some advice from the leaders in the field, we get to take some action. Some of those actions including adding organic matter to our site. That means adding compost, organic matter like leaves, wood chips, and then what the key is here is to like keep it cost effective, right? We don't want to go out spending a ton of money to fix our situation, because if that was the case, we would just go in there, scoop out soil, have it dumped somewhere else, and then bring in new soil. But we all know how costly that is. And besides, when we're doing that, we're just bringing our problem somewhere else to be done. So we have the opportunity to fix it ourselves. Here's some of the youth at GTC and our back site that we are remediating. At GTC, they've been for 20 years since they've been on the site remediating that soil, whether they know it or not, through their practices. So here's some cover crops that we added to our site. This is a nice mix of plants that will occupy different spaces, as Nancy mentioned earlier, where we'll have some silage radish that will go deep and make will break up some of that compaction. Then we have some peas, we have some buckwheat, barley, common oats, all serve different purposes and occupy spaces differently below ground and above ground. So you want to create a plant list next, right? When you're remediating the soil, we're talking about adding organic matter, adding what's missing, right? So if we're seeing bare soils and whatnot, we want to get some plants in there. We want to get some roots, some structures, and these plants are selected carefully as a mix of plants. We often grow like greens and medicinal plants, along with cover crops and plants that occupy different space above and below ground. So here's our plants. We just kind of laying them out in our space. And as you look at this lot, thing I'm finding about bioremediation is that the earth will heal itself. It'll take care of itself. The only thing is it's going to take a very long time to do so, depending on the sill or the contaminant. So if we were to leave this lot alone and not do nothing to it, all of those plants and weeds will go crazy and the soil will start to remediate itself, drawing life in various ways. So what we want to do is just try to like accelerate.
Andrew? You're not screen sharing anymore, sir.
Oh, okay, let's check that out.
Maybe you can just go back go back one slide.
Yep. Can you see my screen now?
Not yet.
I might have to rejoin the meeting. You said.
On my screen, sorry to
Okay.
interrupt you. I'm sorry to interrupt you, but on my screen, I have an icon of a telephone, which indicates sometimes like a internet issue. So you might just want to check your internet connection. Sorry about
Okay,
that.
thank you.
Sure.
Oh, thank you. There. Just a sec. All right, it's letting me in the meeting. Can you guys still hear me?
Yes, we can hear you.
Okay.
Okay.
You got my screen now too?
Yes, we have your screen. Yeah, there we go.
Okay.
Okay.
Sorry
Yep.
about that. I don't know what happened. So
Andrew, sorry to bother you, but do you mind going back a couple of slides just so that we can see what we missed? Just
Oh, yeah.
quickly. Thank you.
So we want to create a plant list of plants that you like to grow, plants you like to see studied, if you're going to be able to send out some tissue samples, and plants that are remediators. And I was wondering, Nancy, if you could, if you don't mind jumping on and kind of explaining. I wanted to say that these plants we got are remediators, but would that be correct?
Well, since all plants have a relationship with the soil, they have a potential to be those. Some of the ones that you selected are known remediators, and other ones are suspected, and some of them are unknown. So you had a bit of all at the table with you. So, yeah.
So it's not necessarily that like one plant or one particular thing is going to do the job, but it's like the community of all of it together. So here's our site here. And just like, yeah, the site all around it, the only reason why it's looking the way it is because it's mowed regularly. So we have our site mapped out where they don't mow. But like I was saying, I believe the earth will remediate itself, and we're just trying to push that process along. So we went document crazy. You know, when I seen these are beautiful photos to me. And it's like literally mold, and I think this is slime mold. You can see some of that white kind of mycelia creeping along there. So we're starting to see life and change happening. We're taking up close pictures of all the fungi that's coming. We inoculated wood chips with a mushroom, I believe oyster mushrooms, but none of these mushrooms we've seen so far are the oyster mushrooms. Here's some more fungi. See the plant enjoying that. I mean the flies. So I've been obsessed with picking these mushrooms up and just like checking the bottom of them and just trying to see that that mycelium, because I've always thought that a mushroom was sort of like a plant where it had its like roots or whatnot, but the reality is that it's mycelium that has a fruiting body of a mushroom. So all underneath our foot. You got a question? Okay. So I wish Willy was here to kind of help with this. Do you mean like, so if we grow mushrooms that are in a site that's contaminated, or do you mean like? Okay, yeah. So Nancy, I don't know if you can help me with this one. But somebody asked if we have mushrooms, if we find these on our site, and we're trying to grow, our plants or whatnot. Are we worried about the presence of the mushrooms?
No,
do we have to like?
I'm never worried about the presence of mushrooms in a garden site. Yeah, it's a positive. It's a reflection of the fact that you have some good carbons there for them to feed on.
But yeah, I'm like lifting all these things up. I'm looking underneath, and I'm just trying to like find it. And I've even like kind of spread out near, just trying to see how far is this mycelium reaching, just out of interest and curiosity. So on our sites, since you can see like the growth here of some of the plants that we installed, whether it's cover crops or some of the mugwort or weeds that are just creeping in on their own, and then some of the plants we installed. And biodiversity has, I kind of made up this number, but to me it's increased by at least 40%. Our actions have led to an increase of life present from finding earthworms to bunnies. So where we started off not seeing any life, no worms in the soil, we ended up seeing worms, bugs, bees, and even a bunny who nestled himself within these plants. But we even found some of these pill bugs, and so what I've been reading on the internet is that these are also remediators, and they can remove heavy metals from the soil. still doing more research on that, but it's always just good to see that our soil food web is kind of there, and that's kind of like where this picture is kind of showing you. Particularly, I saw this picture on the. I'll post the link of where I got it from, but this is kind of like showing you or asking the question: is underground silent? You know, like we think of it as a silent, dead quiet place, but is there like some sort of communication under there? It's a question I ask. And if you know anything about that, Nancy, I'd love for you to chime in. This is our soil food web where we want to just create that diversity above and below ground. So here's a pea plant that comes in our mix for cover crops, and this is cool because you get to see the bacteria that colonizes itself here on the plant. So I think I stretched that picture too big, but on that pea plant, we'll have little pink modules of bacteria colonies forming. And so when they say that the pea plant is fixing nitrogen in the soil, they're actually talking about that relationship it has with the bacteria. So microtraps, speaking of all that underground life, is one way to introduce ourselves to the world underground. So what we're doing is we're taking some half-cooked rice and we're wrapping it up in burlap like a burrito, and we're burying it 4 to 6 inches underground. Sometimes we'll lay them on the surface or under some leaves, and we'll set it there for a week, more or less, depending on the temperature and the humidity. And we'll go back and we'll uncover them to see what we find. So we're not going to, of course, see the microbes with our naked eye, but they represent themselves in color and also in mold. So you can see that there's like some yellowish here, which I like to call the curry chicken yellow, that comes brighter on some of our other traps. And we have some greens, and you can see the mold. So here's a picture of us just digging the traps into the ground and marking our spots so we can go back. There's been a couple times where we've buried microbe traps and then couldn't find them. So don't know if they've got eaten or we just misplaced them. So here's just a closer look of what that looks like. So after you bury that rice and you get to look and see that, oh yes, there is life. It is visible to some extent. Here we're doing these are all part of our actions as to figure out our space, and then also to keep adding different bacteria and things to our plot. So this is our team. We have GPC grows many comfrey plants on their site. So what we're doing is chopping up some of this comfrey, and we're gonna just soak it in some rainwater and let it sit there for months at a time until we get this stuff right here. And hey Nancy, would you mind chiming in a little bit more about like what it is that this stuff is and what it does for our soils?
I think in any plant fermentation, what you're doing is you're concentrating the minerals that has been produced by the plants, and it's grabbed from the soil, and you are making those minerals more, I would say activated through their fermentation. So they're right now, because they've been fermented in water, they're anaerobically populated. So anaerobic bacteria, or bacteria that has less of a relationship with oxygen, and they can be used as soil amendments, usually not sprayed directly on plants, but usually used to drench in soils to mineralize and kind of jumpstart some microbial life.
This reminds me of our conversation we had about, kind of relating this to how humans drink tea and the properties, it gives us from drinking the tea and the way it makes us feel. It kind of is like, similar thing to the soil in some cases. So when we're ready to use this stuff, it's very strong. You don't need a lot, so we're diluting it 500 to 1. We're going to use rainwater or filtered water, and we're going to apply this on our site. Okay, compost is a big deal as far as, you know, being able to create it instead of buy it. So we're fortunate on our GTC site that GTC is already in the mix of getting compost situated. Let me know if I lose my screen again. So we have different methods of doing compost. Right here on the right, we have our keyhole garden, which when, you know, I'm looking for different compost methods and stuff, I always try to see if there's, you know, some indigenous practices or some, you know, African practices that can kind of like touch to our roots. A lot of times I'm looking on YouTube and we don't have good representation. So we deliberately picked these methods as methods that were, you know, of our people and older methods. So this, we're using a pipe that has like a bunch of holes in it to try to get some air down in the middle of that. And we're just messing around at GTC with different compost bins. So here's a long pallet that we were able to get from a siding contractor. And the rest of the pallets we got from various, you know, plumbing businesses or in the back of, you know, a big box store or whatnot. So you can see that we can make a pretty efficient system out of using material that it would be waste or just thrown away in some way or form. So this is pretty good. It's a good system, 4-bin system. We're able to flip and rotate our compost. So this is something we're already doing at GTC that we're able to take from and remediate our soil. And the special thing about GTC is that we're able to expand the knowledge that we receive through working at these sites and apply it to all of our space. Because you don't need to have contaminated soil or it doesn't need to be a toxin or pollutant to help remediate your soil. You know, maybe you just planted a lot into that particular space and, you know, you're taking up all the nutrients in the soil. Or maybe it's a soil that's compacted or has been tilled or whatnot. So there's many reasons for doing this type of work. We're quick to fill it, fortunately and unfortunately, as far as like waste goes, whether it's food or yard waste. Here's another version of a compost bin we built on Franklin Street. This one is also being filled up and used and flips regularly. So it doesn't stop. We're going to continue to do observations throughout the process, and we'll keep documenting and sharing with our consultants so we can know what we're dealing with and know how to move forward. So we want to help heal the soil to the point where immune systems of the plant and the soil are strong and healthy. Insects, disease are attracted to strong, healthy plants. People consuming these plants will get most highly nutritious food possible to grow. People want to overeat because their body want to be craving essential minerals, carbohydrates, amino acids, or liver. Diseases such as diabetes, cancer, heart disease, the autoimmune disease will become things of the past. Children will grow up to be able to develop to their full potential, their full genetic potential. Their intelligence and strength will no longer be limited by malnutrition or toxic chemicals. So that's the hopes, especially in the city when we're remediating the soils. It's not a science experiment. It's us taking advantage, or not taking advantage, but taking our spaces and making them viable spaces and productive spaces. The earth will eventually heal itself. We're just here to help speed up that process with all we know about Mother Earth and her soil. If you guys are able to visit any of the NOFA website, we have more on our project. We have a few more slideshows, and we have a podcast that you can listen to to better explain some of our processes and how we started this project. You can also find it on YouTube. And up next will be our GTC youth that will be creating a video about their site. And then we want you also to visit our farm store and our website at Gardening Community to support our youth. They're doing great things in the community, and they're pretty much in my eyes in Springfield the hub for this type of work. So thank you, and wondering if we have any questions. How we doing, Sister Dora?
I don't see any questions in the chat yet. Oh, wait a minute. Let's see. No questions yet.
Hey Nancy, is there anything that that I may have said or said wrong that you want to touch on?
It was a beautiful presentation, Andrew. I think one thing you said that I thought was an interesting observation, that you said that you've been looking for compost technologies that really get back to your roots and come from Africa and other places, and where people have been doing things, have been connected to land for a long time. And actually, I think about just in Mexico recently, and it was really clear to me. It's like, it's hard to talk about compost because everything just goes to the animals or stays in the field. And so the idea of not feeding your chickens and turkeys and pigs with your waste would be, is kind of a big concept. So composting isn't necessarily necessary in a lot of contexts because it already is connected to animals and then connected to earth. But I think, now with how we've organized our lives very far away from land and with so much surplus, and that composting does make sense because we do need to build our soils, and there's waste everywhere in our cities. And so composting is something that's more kind of a new technology because it's been needed, but not necessarily you can find years ago or in places that are still very connected with their land. So I just wanted to point that out.
That's very smart. That reminds me too about this. What is it in the area, right? Like you can't just assume that everything is for everywhere, and or everything is for everyone. Like you can't go into a vacant lot assuming I'm gonna do this playground and set it up, and then you don't talk to the community at all about what they want, and come to find out, there might be children on that block that are that have wheelchairs or that are blind. And so how do we accommodate them on the playground? Did anybody think about that? So I even think about that when I go into these spaces, like I'm going to remediate this and make it a garden, and we're going to take care of this land. But what is it that the community wants? What is it that the people want that are there in the area? I think is important.
Andrew,
Yep.
What interested me was that bug you showed, the round circle bug. I used to hate bugs. I used to hate seeing those bugs, but you can you elaborate again on what they do to the soil? Those
Yeah.
they turn
that's
into
something
a
that
ball.
I want to learn. Yeah, that's something I'm learning. I just know that I read very briefly articles saying that they are able to remove heavy metals. And I don't know if Ruben or Nance know anything more about their involvement in this process. It's cool to see any of these bugs that have any kind of skill set to take something and make it a better situation.
Yeah.
I know that they are actually a very important part of the, like you mentioned earlier, a part of the different trophic levels in soil, a good soil health indicator. They are grazers or decomposers of carbon and dead plant material. But it's interesting, actually. I didn't know that they were bioaccumulators, so I would like to learn a little bit about that too, actually.
Thank you.
I would probably think that all of those decomposers are remediating in some ways because they are involved in the process of decomposition of things smaller than them. And so I haven't looked at any studies, but I also just made a note to look at them when you brought them up. So thank you for that. That's going to be interesting to look into.
I had another question, and I apologize if I was a little off track, but you showed that square, looked like a sandwich, that little square thing with the yellow bucket around it, with the mud in it. Yeah. Can you elaborate on that a little more?
Yeah, that was months of fermenting that you've seen there. The reason why it looked like that mud, it was kind of sitting on top of the watery mix. That was comfrey. And from what I understand, please elaborate, anybody. But from what I understand about comfrey, is that it's very good at getting certain minerals and nutrients from the ground. And then it uptakes it throughout its plant body. So we're able to, chop that down and let it sit and ferment into the water, grow those properties, and then, introduce them to our soils. I'd definitely like to hear if anybody else has a better answer to that.
So if you're gonna grow
Because
something,
everybody knows that I love comfrey. I go around, as soon as it's ready to be chopped down, I chop it down. I start, getting it ready for the buckets or whatnot, because it's something that I don't always completely understand. But I do know that when there's a plant like that that's on a site that we're not necessarily using at the moment, I'm just going to try my best to use it in the way that I know it should be used, and then figure out why as we go along.
yeah, thank you. Sister Anna put a question in the chat. Well, she put a comment. She says, pill bugs do take in heavy metal like lead and cadmium. They crystallize, yeah. They crystallize these ions in their gut. So those pill bugs, so if you're gonna have an urban garden in the city, best to get those bugs, right? That's what I'm looking at. That's what I'm thinking. It's best to have those bugs.
It really reminds me about, I think I've heard Nancy say this before. It really reminds me of community. Like, there's so many things that I want to, be involved in community. And for a time, I felt like, I'm going to do this alone. I'm going to find this plot of land and I'm going to remediate it and grow on it and sell food and make a difference, But when you're actually doing the work, you realize how much it takes and how easier and smoother it would be if you had more people involved. And not just more people, but different types of people with different types of inputs. And then not only just people, but just then, like the space, the money, whatever tools, anything we need. So I look at, the diversity in the soil, having not just a pill bug or not just like a comfrey plant, but all of it all together is like a thriving community. That's the best way I can think of it to make it make sense to me.
Well, thank you, Andrew. We have new people who just came in maybe 5 or 10 minutes ago. You have any questions, you can put the questions in a chat, or if you would like to ask a question now, feel free to do that while the phones unmute your phones and ask your questions. We're talking about the bioremediation of urban soils. We have Andrew Laurion on the phone along with his co-host, co-presenter Nancy Clem. So feel free to ask your questions if you have any. Let's see if something came in the chat. Oh. Nancy Clem. You want to come off of mute, Nancy? Come for your
Oh,
cumulative.
Yeah, I just wanted to say that many plants that are used in plant ferments are used because they accumulate, they hyperaccumulate, like Ruben was talking about, certain minerals within them. And so the idea of using them as a amendment is it allows you to develop, deliver those minerals to the soil. And so I just wrote that comfrey accumulates phosphorus, potassium, calcium, magnesium in its body. And so that's why it's used as a plant ferment. It's also probably is pretty abundant. I don't use plant ferments that aren't abundant on site. So it's a little bit of what's around and what I can use and kind of what whatever I'm growing and what it needs. And so, yeah.
Thank you. You want to share any last words, Andrew? Or if there's any questions, you can put it in chat or come off of mute, ask your questions. If not, Andrew, you have any last words you would like to share with us? And Nancy.
Yeah, no, thanks tons to everybody here that's on this call, especially to Nancy and Sister Anna for being, by my side throughout this whole process. And also a special shout out to, I'm muted? Oh, no, that's on the screen. They can hear me. It's the phones right here. So yeah, I'm here with the youth from GTC. They've all been here patiently, watching the event. There's been a couple of questions that came in, so I want to thank them, and they're doing like great work, and for them to even like show up to a program like this is powerful. So I want to make sure that all you guys are aware of the youth and all the hard work they're doing, and that they feel appreciated and they know that it's important.
Yes, sir. Well, thanks again. We thank you so much for all the great insight and information that you shared with us today. We would like to say thanks again to for our sponsor, MDAR, the Massachusetts Department of Agricultural Resources, for sponsoring this event. And thank you very much for everyone at the NOFA staff. We look forward to seeing you again. So thank you all for joining us.